Have you ever walked into a room and thought, maybe the room feels a little too warm, too humid, too dark, or the air just feels a little heavy? Most of the time we just guess, but what if we can actually measure it? Today, we're introducing Insight1's Air Detective Station Kit, a hands-on environmental monitoring project built with the ESP32. This project helps learners explore electronics, coding, sensors, data display, and environmental awareness by building a real device that can monitor the world around them. In simple terms, this is a small environmental monitoring kit. It can measure temperature, humidity, air quality, atmospheric pressure, light intensity, and PM2.5 particles. Then it displays the information on a color screen in real time. So instead of just saying the room feels hot or the air feels stuffy, this device can show actual data. Basically, it turns your room into a mini science lab. But don't worry, there are no lab coats required. At the center of this project is the ESP32S3 development board. The ESP32S3 acts as a brain of the system. It connects all the sensors, processes the data, controls the display, updates the status LED, and runs a program that brings everything together. This makes it a great learning project for beginners because students can see how code interacts with real hardware. They are not just typing code and looking at a computer screen. They are building something physical. They can touch it, test it, observe it, and improve it. Let's take a closer look at the main parts of the Air Detective Station. First, we have the AH220 BMP280 sensor, a combination sensor that gathers more data. For its AH220 sensor capabilities, this sensor measures temperature and humidity. These are the two of the most common environmental readings. When the temperature rises, the reading changes. When the air becomes more humid, the humidity value changes also. For its BMP280 sensor capabilities, this sensor measures atmospheric pressure. Pressure data can be useful in weather-related projects and environmental monitoring. Next, we have the SGP30 sensor. This sensor measures eCO₂ and TVOC. These readings help us understand air quality. eCO₂ gives an estimated carbon dioxide value, while TVOC refers to total volatile organic compounds. This can be related to things like indoor air freshness, ventilation, and air quality changes. Then we have the BH1750 light sensor. This measures ambient light intensity in lux. If the room gets brighter, the value increases. If the room gets darker, the value decreases. Finally, we have the DC01 PM2.5 sensor. This sensor measures fine particles in the air. PM2.5 particles are very small particles, so this is an important part of environmental monitoring. Together, these sensors allow the device to collect different types of environmental data, from temperature, humidity, and air pressure, to air quality, light, and PM2.5. After knowing what each sensor does, it's time to start wiring them. This is one of the most important parts of the project because the sensors, screen, and ESP32 all need to communicate properly. If you are a beginner in electronics, don't worry. Insight1 always provides step-by-step guides to help you wire and connect the modules and sensors correctly. Wiring done! If you are doing the wiring along with me, it should look a lot like this. Speaking of wiring, this project teaches important hardware concepts. Several sensors use I2C communication. This means they can share the same SDA and SCL lines. In this project, the HG20 plus BMP280, SGP30, and BH1750 can share the same I2C bus. To ensure that the system will work properly, carefully check the wiring guide to make sure everything is correctly connected. Once the wiring is ready, we can move to the software side and upload the program to the ESP32S3. The Air Detective Station project uses Visual Studio Code and the PlatformIO IDE's extension. If you haven't downloaded it yet, I'll guide you through it. First, download and install Visual Studio Code on your computer. After opening Visual Studio Code, select the extensions icon on the left side of the screen. Search for PlatformIO IDE and then install the extension. Once the installation is complete, you should see PlatformIO icon on the left sidebar. Next, select File, then Open Folder, and open the complete Air Detective Station project folder. Make sure you open the main folder containing the PlatformIO.ini file. Once all the necessary software tools are ready for use, we can now connect the ESP32S3 to the computer using a USB cable. The complete project code is provided so that beginners do not have to worry about writing the whole program themselves. Open PlatformIO in Visual Studio Code and select Build. This checks the code and compiles it for the ESP32S3 board. If everything is correct, the terminal should display the word Success. Next, select Upload to transfer the program to the ESP32S3. If the upload gets stuck at connecting, hold down the boot button on the ESP32S3 board. Start the upload again and release the boot button once the upload begins. After uploading the program, open the serial monitor and set the baud rate to 115200. Now that the hardware is connected, the software is uploaded, and the dashboard is working, we can start testing how the device responds to real environment. At this point, the device is no longer just a collection of parts. Honestly, it probably knows more about the room than we do. Now, all of this data would not be very useful if we could not see it clearly. This is where the 1.69-inch TFT color display comes in. The display shows the readings in a simple dashboard format. This makes the device easier to understand, especially for beginners. Now, let's power it on. When the device starts, it first runs a boot self-test. This checks whether the system modules are ready. On the screen, we can see items like I2C bus, display, H220, SGP30, BMP280, BH1750, PM2.5 UART, WS2812B, buzzer, and EC11 encoder. Some items may show OK, which means the module was detected or initialized. Some items may show set, which means that the peripheral has been configured, but it does not always guarantee that real data has already been received. After the boot self-test, the main dashboard appears. This is where the Air Detective Station starts showing live environmental readings. The device samples data regularly and updates the display. The H220 row shows temperature and humidity. The SGP30 row shows eCO₂ and TVOC. The BMP280 row shows atmospheric pressure. The BH1750 row shows light intensity. The PM2.5 row shows particulate concentration. There is also an update time so learners can see that the system is actively refreshing. Let's try a simple demonstration. If you cover the light sensor, the value should go down. If you shine more light towards it, the value should increase. These are the current readings for this room. Now, what if you move to another room and test the air quality there? Oh, we can see that some values have changed. I think we can do one more. That's fun. You can see the data change in real time. Now, let's discuss the changes and the explanation behind it. We tested the Air Detective Station in 3 rooms and found clear differences. Room 1 was the coolest and had moderate gas readings. This suggests the room may have had active air conditioning or better ventilation. However, it recorded the highest PM2.5 level, possibly from dust or smoke. Room 2 has the highest estimated readings. The room was also warmer and much darker. These changes may indicate poor ventilation or closed windows, or the presence of substances such as perfume. Room 3 was the warmest and brightest, but it had the lowest estimated carbon dioxide and TVOC levels. This suggests it may have had better airflow, open windows, or stronger ventilation. The higher temperature may have been caused by sunlight entering the room. Its PM2.5 reading was also very high, possibly because outer dust or pollution entered through an open window. This makes the Air Detective Station kit especially suitable for STEM learning. It connects environmental science, electronics, programming, sensor technology, data visualization, and product design in one hands-on activity. Students can start by thinking about how this Air Detective Station could be used in a smart classroom, smart home, or smart city system, and then think of ways to improve it like alert thresholds, data logging, or connecting multiple stations to better monitor an area. This is where AIoT becomes exciting. AIoT means combining artificial intelligence, internet-connected systems, sensors, and smart devices. Even at the beginner level, this project introduces the foundation of that idea. Collect real-world data, process it, display it, and use it to make better decisions. Today, it monitors one room. Tomorrow, maybe the whole city. Okay, maybe not tomorrow, but it is a good start. This project is perfect for students, beginners, educators, and makers who want a practical way to learn coding and electronics. For beginners, this project is valuable because it starts with something real. Students do not need to imagine what the code is doing. They can see the screen update, they can cover the light sensor and watch the lux value change. They can compare readings in different rooms. They can check if wiring changes affect the system. And most importantly, they can understand that technology is not magic. It is a system. Although, when everything works on the first try, it does feel a little magical. Again, this is Insight1's Air Detective Station, an ESP32 based kit where learners can build their own environmental monitoring device and start exploring the data around them. Because when we can measure our environment, we can understand it better. And when we understand it better, we can design smarter and healthier spaces. Don't forget to subscribe and follow our social media platforms to stay updated with our latest learning kits and products.